So for problems number 22 through 29, we're going to be using the same diagram here on the right. And we are given that R and S are parallel, which we can sometimes denote by putting little arrows such as that, showing that that direction is shared by R and S. And also lines G, H, and K are parallel, which we can denote like such. We'll have a double arrow on each one of those. The reason we have a single arrow on this set of lines and a double arrow on this set of lines is just to indicate that these three lines are parallel to each other and these two lines are parallel to each other, but these two lines are not necessarily parallel to these three, and that's what the different symbols mean. The fact that this is just one arrowhead and this is two, obviously this can't be parallel to this because they're intersecting, right? Okay, so we end up having these 5 lines, and they create lots of angles. In fact, there are 1, 2, 3, 4, 5, 6 points, each of which have 4 angles. So we've got 24 angles in total, of which 10 of them are labeled, and for which we've got questions about those 10. We need to determine whether or not the statement can be justified as being true. And let's start. Does the measure of angle 1 equal the measure of angle 2? Let's take a look at 1 and 2. So 1 and 2 have a relationship. Okay, they both have the same transversal, which is R, and R cuts across G and H. And so it creates these 2 points. And if you notice, both 1 and 2 are the upper right hand position in relationship to each of the corresponding points. So they are corresponding angles. And we learned a theorem that if lines are parallel, corresponding angles are congruent, which means their measures are equal. So this is true because they are corresponding angles. Okay, now let's look at whether we can justify that the measure of angle 2 equals the measure of angle 3. So those are these 2 angles here. Well, what kind of relationship do they have? Try to identify it by yourself, and then I'll tell you. Well, first look at the transversal that they have in common. They have H in common, and H creates both these angles as it cuts across R and S. So R and S are the parallel lines, and 2 and 3 are both interior to those lines, right? They're between those lines. So these are interior angles, but they're on the opposite side of H, which is the transversal, which makes them alternate interior angles. And we had already learned that there's a theorem that says alternate interior angles are congruent, assuming these lines are parallel. So this is true, and we have that because of the alternate interior angles theorem. Okay, let's look at problem 24. The measure of angle 4 is equal to the measure of angle 6. This is 4 and this is 6. I hope you see right away that's true because of the vertical angles theorem, which we will be proving in a few days. But we already know it. We know that vertical angles are congruent, that their measures are identical. Let's look at this next assertion. Angle 7 supplements angle 8. Is that true? Here's angle 7, here's angle 8. Are they supplementary? Can we prove it? Well, do they have a relationship with each other? They do. They both share transversal S, right? This line going up and down transversal S as it cuts across lines G and H. So 7 and 8 are between G and H, makes them interior angles. And are they on the same side of the transversal S? Indeed they are, yes. So they are same side interior angles. And we already know that same side interior angles are supplementary. So this is true because they are same side interior angles.